Texas Math Mundo audience. Today we have an addition to our instructional series. The topic, overflow and underflow problems. These are typically found in the UIL Calculator Applications contest. A lot of my students, especially the newbies, they gravitate towards that Calculator Applications contest because it's a lot of real-world applications, it's tactile, and they really enjoy it. Inevitably, they always want me to show them how to do the overflow and underflow problem, which is typically found in problem number 62. That right ahead. Before we get started, let me take a quick moment and ask that if you enjoy this content, that you please hit the subscription button and the notification bell, that you leave a comment below, and you smash that like button. It really helps me out with the YouTube algorithm. Let's spread this joy, let's spread this beauty to as many people as possible. In addition to our instructional series, overflow and underflow problems, right ahead. My name is Saul Cantu, and this is Texas Math Mundo. Okay, the first problem we're going to attempt is the District 2023, number 62 from the Calculator Applications contest. And the problem states, the probability of getting heads in a coin toss is 1/2. What is the probability of tossing heads 1,000,000 times in a row? And this is the thing with these overflow and underflow problems. They always have an interesting context. Can make the problem kind of interesting. So what is the probability of tossing a head 1,000,000 times in a row? So that would be 1/2 raised to the 1,000,000. But the issue is, if you try to put this in the calculator, we try to put 1/2 raised to the 1,000,000, 4, 5, 6, and you get an error message. This number is way too small for the calculator to handle. Calculator can't do it. It's way too small, and hence it's called an underflow problem. So inevitably my students find this fascinating, and they ask me, Mr. Cantu, how do I solve this? I solve this? And let me show you how I would teach them. So first I re-express this, knowing your exponent rules, that this is the same as 2 raised to the negative 1,000,000. And I say, okay, let A equal to this quantity. And of course, that's what we're seeking. We're seeking this A. We're seeking A because that's the equivalent. Now keep in mind the rules in calculator. The rules in calculator say you have to express your answer with 3 significant digits, and you can do it either in standard notation or scientific notation. So of course, we're not going to express this in standard notation. It would take forever. So the key is to write this answer in scientific notation. So here's how we go about it. I'm going to take the common log of both sides. So when I take the common log of both sides, you got to know your logarithm rules. We got something called the power property. We can put the power to the front. And so when we do that, we got log of A is equal to a negative 1,000,000 times the log of 2, which has the effect of scaling down the original problem. And we can actually put this into the calculator. And when we put this in the calculator, so negative 1,000,000 times the common log of 2. So negative 1,000,000, 1, 2, 3, 4, 5, 6, times the common log. And now you just put base 10. Back in the days, we could only do common log or natural log. Common log of 2, and you get the following answer. So we're going to put that down. So log of A, remember we're searching for A, is equal to negative 301,029.995,664, if I'm correct. Let me take a quick look. It's 5. Good. So here's the issue, and here's the tree. We're going to separate this into the integer part and the fractional part. I believe these have, I think this is called a characteristic, and this is called a mantissa. I've seen this vocabulary throughout the years. We're going to separate it out. So when I separate it out, the key thing to remember here is the mantissa or the decimal part can never be negative. So the way you're going to remedy this, you're going to add 1 and subtract 1. So you're adding 0, so the original value is unaltered. Well, that negative 1, I'm going to go ahead and put over here. And when I add 1 to the decimal part, I get a positive decimal. So continue our work. Log of A is equal to, and now that's going to be a negative 301 0.1030 because I've added the negative here. Now plus, now I can have the decimal part being positive. And I need 1 plus that decimal part. So 1 plus the decimal part, which is 0.995664 and 0.004336. 0.004336. And now we can get back our A, which was what we were searching for, but in a form that the calculator exam accepts. So I just exponentiate. I raise both sides to the 10. Well, the common log and the exponent of 10, they undo each other. So you get A, was what you're searching for. And here, remember common base multiplication, you add the exponents? Well, we can separate it out. We can put 10 raised to the 0.004336 times 10 raised to negative 301030. And you can put this into the calculator. And if you get a number between 1 and 10, then you have proper scientific notation. So let's go to put this into the calculator. So we're going to raise 10. So 10 raised to the 0.004336. And with 3 significant digits, that's 1.01. And your answer is 1.01 times 10 raised to the negative 301030. And that would be your correct answer, suitable for the UIL Calculator exam. 3 significant digits, written in scientific notation is acceptable. Of course, you're not going to try to write this in standard notation. And there goes your answer. There goes your answer. That's how you do underflow problems. All right, our next problem is from the year 2022, the state exam calculator applications, number 62. The question says, the odds of being dealt 4 aces in 5-card poker is 1 in 54,145. What is this number raised to the negative 23,639? So 1 over 54,000, 145 raised to the negative 23,639. So if you were trying to do this on the calculator, again, you'd get this error message. So it's 1 divided by 54,145. That number raised to the negative 23,639. And you get an overflow this problem this time. Now it's overflow. So how do we do this? And this is pretty fascinating. So what is this number? So the way we do it is similar. This is now an overflow problem. This number is too big for the calculator to handle. And so if we're going to write this number, we're going to have to resort to similar methods to the first problem. So I said let A equal, and the way you change this negative to a positive, I'm just going to re-express this as 54,145 raised to the positive 23,639. Again, I'll take the common log of both sides. And when I take the common log of both sides, I can use the logarithm property, the power property, to put the exponent, the power, in front. So I end up with log of A is equal to 23,639 times the log of 54,145. You put this into the calculator, scales down the problem. So let's go and do that. So we're going to put in 23,639 times our common log, which is base 10, of 54,145, and we get the following answer. So let's write that down. And this is going to equal to 111,896.587 5.86025. And the key is to separate the integer part and the decimal part. So that's equal to 111. So let me do that up here though. So you end up with log of A is equal to 111896 plus, and the decimal part is 5.86025. 5.86025. And this decimal part's already positive. Unlike the underflow, the overflow, you already have a positive decimal part, so we're completely cool to proceed. Again, to get our A, because A is what we're searching for, now you undo the logarithm by raising that by 10, raising 10 to that logarithm. In other words, doing the inverse function. And so the A pops out, is what we're searching for. And again, common base multiplication, you add the exponents, we can reverse that. So we're going to get 10 raised to the 0.5866025 times 10 raised to the 111896. And if this turns out to be a number between 1 and 10, we have an incorrect scientific notation, and we have a good answer for the calculator exam. So let's go ahead and do that. 10 raised to that decimal part. So let's do it. It's going to be 10 raised to the 0.5866026. And we have 3.86 for 3 significant digits. And so our answer is 3.86, the number between 1 and 10, times the power of 10. And if you can imagine moving that decimal 111,896 times, just imagine how big that number is. And that is our answer for the calculator exam. There you go. That's overflow. Okay, now it's time for you to try your hand at some problems. The next problem is from the year 2023, the UIL B release, Calculator Applications, number 62. And let me go ahead and read the problem. It says, the probability of being struck by lightning in a day is 1 in 182 million. What is the probability of being lightning struck 1,000 days in a row? I guess that probability would not be 0, but it's awfully close to 0. So let's go ahead and pause the video and try your hand at it. And I'll fast forward to my work and see if your work agrees with mine. So there you go. Go ahead and pause the video. And there goes your answer with the work shown. So you can check your work against mine. Typical underflow problem, you have to add 1 and subtract 1, so you get the positive decimal part. And there you go. All right, our final problem for you to try, and I'll fast forward my work, and you can check your work against mine, is from the year 2021, the UIL B release, number 62. And it states, there are 3.72 times 10 to the 13 cells in the human body. What is this number raised to 2,530 power? Wow, that's got to be a very big number. So go ahead and pause your video, see if you can deal with this problem, and we'll check your work against mine. Okay, go ahead and pause your video. And that is your answer. There were some tricks there, a little variations, a little twist there, but I hope you can follow my work, and I hope you learned something today. So there you have it. That is my treatment of overflow and underflow problems. They often have fascinating context. It never fails to inspire the kids to learn how to do it. The answers look unique. So I hope you enjoyed that. I hope you learned something. Let me take a quick moment and ask that if you enjoy this content, that you please hit the subscription button and the notification bell, that you leave a comment below, and you smash that like button. It really helps me out with the YouTube algorithm. Help me spread this joy and help me spread this beauty to as many people as possible. I got plenty of wonderful things in store for this channel. My name is Logan Johnson, and this is Texas Math Overflow. Farewell.